See. So it creates this trace file, and you can see that the names of the Diana nodes are the ones beginning with D, for instance dcompute, or dsbody, or diproc for procedure, d_p. The values that are below those are the attributes that we talked about previously, and they are some of those are pointers to other nodes, so that creates the tree structure. Some of them are lexical attributes. So for instance, lsimrep is a lexical attribute which stores the name of the procedure. Every node has an L source position, which shows the source position, row and column, in the original PLSQL source code. All of the ones beginning with A are structural attributes, so they are pointers to other nodes in the tree. The ones beginning with S are semantic attributes, which are populated during the static semantic phase of the compiler. And the ones beginning with C are code attributes, which have got something to do with the code generation. And that's what the slide shows there, although it's a little harder to see when you try and fit it on a slide. Interestingly, this book also shows the same information on page 137 and 144 to 144. This is known as the external representation of Diana. This book states that for Diana to be a valid producer or consumer of Diana, it has to be able to create or read Diana in this format. So attributed structure tree. So there's an example here of the block part of that same trace file. So you can see the D block, DS item, DS statement, and DS alter. They're the three sections of the main body of the procedure. The DS item is local variables, the DS statement is the actual statements in the middle, and the DS alter is the exception clause. We'll see this in a second. The PD syntax is also shown in this same book, exactly the same on page 151. So obviously Oracle has implemented the Diana packages and internal stuff the same as from an Ada compiler. Each node type has a variable number of attributes. We'll look at that again in a minute. Some of those attributes are pointers to other nodes, and some of the things like source position is mandatory. It's on every node. Ada also had another mandatory lexical attribute called lxcomment, which is not in PLSQL. So reconstructing PLSQL source code from Diana. Just looking at the block syntax for PLSQL, this is taken from Ada, but it's basically the same. So the top bit there is actually from the Bacchus no form of the compiler. So showing what the block statement constructed of. So it can have a simple name in Ada. Has a declare keyword. The declarative part is where you put the local variables. A begin statement, that's where you put your statements like if something, else something, or whatever else. And an exception keyword where the exception handler will go, and then an end keyword. Looking at the Diana rules, these are all taken from this Diana book, which is for Ada, but essentially it's the same for PLSQL. The block is made up of three sections: an AS item, an AS statement, and an AS alter, which we saw in the previous slide. Oops. So you can say the AS item, AS statement, AS alter. So that's exactly the same as it was in Ada, because this information on this slide is taken straight from this book. There's an alternative Diana dump that you can do with the dump Diana command. You can actually tell it to dump it in line format instead of as a tree format. I actually find it's easier to read it in line format. So again, for the same body, you can see, for the same procedure, you can see the body. So AD is pointing at the actual body of the procedure. A header points at the parameters and the block and so on. And A up is in quite a lot of them, which is a backwards pointer. Interestingly, in here, Ada doesn't provide a backwards pointer as part of its standard. So going back to reconstructing the source code, clearly we can see to reconstruct that source code, we'd need to generate the keyword declare. We'd need to get whatever's in the item Diana node. We'd have to generate the begin keyword, then do the same with statement, and the same with the exception clause. So you can see there's a very close correspondence between the Diana and the original PLSQL source code. So those numbers that we saw earlier on, 9A, B4, etc., If we convert those hexadecimal values, or we can read them from the trace file as well in here. So if we took ds body, for instance, we can go to the Diana package and find ds body. If I spell it right. Oops. Let's take a different one, di proc. So we find di proc in there, and that's got a value of 154. So for di proc, that maps to 9A, which is what we saw in the wrapped file as well. AB, so 9A there, that's the Diana node for the procedure. So what I've done is, for those same, if you went through the trace file, which is what I did, this trace file here, and picked out all the node names and then mapped those to the decimal values from the Diana package and then convert them to hexadecimal with a hexadecimal converter, you end up converting back to the same list of nodes that we saw originally. So it confirms that the wrapped format is Diana. So how would we actually reconstruct PLSQL source code from Diana? I've just drawn this little diagram to show that the structure of the Diana nodes by looking at the nodes we saw there, and we just get this directly from the trace file from dump Diana. So it starts with dcomp unit, which is the compilation unit, I guess. That has an attribute of body, which has an attribute of procedure, and also one d underscore p underscore, which is the parameters, and also one for the main block, which has then got 3 further attributes for the local variables, the actual statements, and the exception clause. So using that information, we should be able to reconstruct the PLSQL. This pstub procedure that I talked about earlier, this essentially does the same thing. This procedure was shipped when Oracle clients were running PLSQL version 1, and they needed to call higher versions of PLSQL on the server. It was necessary to create a wrapper procedure that could be sent to the server to be executed. And if you actually look at the source code of pstub, because it's not wrapped, you can see that they're actually getting the information to generate this wrapper by using the Diana, not by reading PLSQL source code. So Oracle have actually shipped a PLSQL unwrapper for years with the database. So what we need to do is use the lessons learned from that to do the same thing. There's also another procedure in the same package called subptxt, which is basically doing a describe. So it does a describe of the procedure, same as running the describe command. And again, that uses Diana to get its information. So they're not really demonstration programs, they had a proper purpose, which was to allow version 2 PLSQL to be executed on the server from a version 1 PLSQL virtual machine on the client, which is what it says there. So both read the Diana, not the PLSQL source code. I guess that's because it had to work with wrapped source code and unwrapped source code. The extpr text function, which is in the DI utility package, is an excellent example of how to use Diana and PIDL package calls to actually read the Diana. So if you study that, you can see how to write an unwrapper. So, writing an unwrapper. To be able to write an unwrapper, you need to understand the relationship between Diana and PLSQL language keywords. So you need to know which keyword in PLSQL, for instance, procedure, maps to which node in Diana, which is what we just seen, the di proc node. You need a way to parse the Diana, so you need to get at the Diana. The Diana is either stored in a wrapped file, it's stored in the IDL dollar tables. I guess it's stored in memory as well while it's being executed. One way to do that is to get it from the IDL tables and use the API calls, which are in the Diana packages and in the PIDL package. So you need a way to read and understand the Diana node types. You can get that from the Diana package and also the PIDL. You can actually read a node number like we showed manually, and you can actually see that 9A is the procedure, di proc, and then you can manually convert that back to a procedure keyword. So mapping PLSQL to Diana for some language constructs can be done using test programs and analyzing the Diana. So you can actually use the procedures that Oracle give you, the API calls. So the limitations of a PLSQL-based, API-based unwrapper. there are a number of limitations. The first two lines just saying how it can be done. The diutil gives an example. There's some problems with using the PIDL package because the Diana isn't stored in the IDL tables for all PLSQL. It's only stored for procedures and functions and a few other bits and bobs. But also, even for procedures, it only allows you to access the parameters and the bits necessary to generate the wrappers that we showed in the pstub example. For instance, we're showing in the next slide that if you put some PLSQL statements in the body of a procedure and use the API calls to then walk the Diana, it doesn't actually get them back, and dump Diana doesn't show them either, so it's quite limited. It should be possible to write a complete unwrapper in PLSQL using the same functions, but reading the Diana from sys.source$ instead. So just an example of the limitation. So we've created a procedure here, AH, that's got a body in it this time with an if statement and else statement. If you look at the dump Diana, you'll see that it actually doesn't generate the Diana using the dump Diana package, so it's not visible. So clearly that's not a way to write an unwrapper. Quite interestingly, this script is available on the CD called attrib.sql. We'll just open that up, which I haven't got already. This is just a simple procedure that's using the PIDL package functions that we showed earlier that allow you to get the text name of a Diana node and allow you to find the number of attributes that each node has, and also to get the text names of those nodes, the data types, and so on. So if you run that procedure for a 23, which is decompu, you can see that it's got 9 attributes. These numbers here, 9, 40, 62, they're just individual identifiers. And the text names, these are the actual attribute names, and the data types. For instance, 1, you can go back to the PIDL package, and you can see that 1 is a type of PT node, which is a node, a Diana node. So you can see that's one of the structure attributes that points to another Diana node. So can you create a complete real unwrapper? Obviously you can, because there are ones out there that people are using, and some guys actually selling to people as well. To actually create a complete unwrapper, you need the complete PLSQL grammar. You can either get that, there's the AMTLR of the PLSQL grammar, I'm not sure how complete it is. And also the PLSQL user reference guide includes the grammar for most of the PLSQL constructs as well. To create a complete unwrapper, it would be necessary to understand all the Diana nodes that are generated for every keyword or PLSQL construct, which would be quite difficult. That's not documented. Partly it's documented for Ada in here, in chapter 2. So the sort of core language features, it's possible to find out what Diana nodes are generated from the Ada point of view, but whether they're actually the same nodes in PLSQL needs to be investigated. If you wanted to create a real unwrapper, then it's necessary to understand the wrap file format, because from what I've just said, you can't get it from the IDL dollar tables, because not all Diana is stored, and also for the ones that are stored when you use the API functions, it doesn't actually give you all the information. Quite interestingly, it may also be possible to disassemble the M code back to PLSQL. We'll look at that in a second as well. And the symbols are also embedded in the M code. If you actually look at the M code and show it in hex and use an ASCII converter,